Hey everyone, in this video I'll be building the Armattan SCX200. When I first started my website back in around April 2015, I did a sort of an intro post on how to build a FPV quadcopter. It was using parts that were considered good at the time, but quadcopter parts are advancing so fast that the parts that I used back then, they seem obsolete now. So in this post, I'll be building the best race quad using the best parts I could find as of right now. So maybe I might have to do one of these posts every year just to keep up. So I'm gonna try to do this entire build in one video. So if any time you get lost during this the build, especially in the setup part, you can check out my other videos, particularly the QAVX build. I'll put links in the description below for all the links you need. But it's pretty much the same build with just some small differences. So I'll be using the Armattan SCX200. This is a perfect X 200mm quad. It's a pretty nice frame. There are some really small details on this frame that I really like. For instance, this FPV camera is held in with this little rubber thingy, and then there's a screw back here that's part of the rubber part that locks in the angle of the camera. Because sometimes when you hit a gate, your camera ends up pointing to the ground, and it makes it really hard to fly. So this thing just locks in the camera angle wherever you have it set. And then for the SMA, there's a little brace by this little plate right here. Once you tighten the antenna, it locks the SMA in place and takes all the impact away from the solder joint on the VTX to this plate. It's a simple design, but it's been working well so far. I haven't had any issues with antenna breaks or anything. And then in this setup, I'll be using the KISS flight controller with the KISS 24 amp ESCs. This quad I'm building a little bit different. I'm putting the ESCs on the bottom of the quad because I've had so many ESCs get destroyed by the props bending and hitting the props or the ESCs. One small flaw I can see in putting the ESCs on the bottom is you might end up chopping a wire over here, but I'd much rather get a wire chopped than breaking a $25 ESC. So yeah, I'm using the KISS setup. Ever since I switched to KISS, this is pretty much how I build everything with a KISS flight controller, KISS ESC. This setup flies so good. It's easy to set up and very forgiving on the tune. Even if you don't tune it right, you're not gonna get crazy oscillations and stuff like that. If you're compared to using a clean flight controller. So once again, I've built two quads to see which one is better. Both of these quads are built exactly the same. Same flight controller, same ESC, same video transmitter, everything. They're the same except for the motors. I heard so many good things about these T-Motor F40 motors that I decided to give them a try. These are the 2300 kV version. They fly really smooth and responsive, but for the raw power, these new Emax RS2205S 2300 kVs are so sweet. When I fly the F40s, it feels like I was at 100% throttle a lot more often than the Emax. Whereas the Emax, I felt like I still had some power left in the throttle if I needed, especially in the straightaways. And then since this will be set up as a race quad, I'll be using this FX799T, which is a 40 channel, or is a 200 milliwatt 40 channel race band transmitter. It's only around 30 bucks and it's been working great. Simple one button operation, and it gives a really good image, and I haven't had any issues with them. And then on the quads, I'll be running the good old Foxier HS1177 with the 2.5 lens. This 2.5 lens is a must-have for racing. This 2.5 will give you a field of view about 110. On the standard 28 millimeter lens, you only get about 85 degrees of field of view. This makes seeing your turns and gates really hard. With a small field of view, it's really easy to get lost on the track and you can't see where you're going. So highly recommend using a wider lens when you fly or when you race. Okay, so let's get started with the build. So the first thing we're going to do is we're going to install the arms on the frame. So we're just going to take one of the arms like this, get one of the longer screws and stick it through the top of the arm. And then you're going to get these little metal thingies and push them through or screw it on the bottom. I'll just show you how to do one and then the rest is pretty much you can figure it out. Screw that in. You want to make sure you get this one tight enough to where this little metal thing goes down into the frame, because that's what's going to lock it in place. So now that we've got the arms installed on the frame, now we're going to prepare the ESCs to be mounted with the motors. So I'll just show you how to do one of them and then you can figure out the rest. So once again, I have my little cheat sheet here, and then I'm just going to cut the motor wire to the appropriate length. And then I'll do one of the ESCs. So I'll just do ESC 1 right here, and this is for the ESC signal wire. Sorry if I sound kind of stuffy. I'm still getting over a cold right now. And then for the power wires, it doesn't have to be exact because we're going to pull it tight and then pull it tight to make sure the ESC is not flopping around. So just cut like, I don't know, maybe 1.5 inch for the power wires. I'm just going to use black for both positive and negative just to make it look cleaner. Alright, so I just stripped the motor wires and tin the ends along with the power cables for the ESCs, and then I'm just gonna pre-tin the ESC also. So make sure you have the side with the signal pads up. So I'm gonna tin these really quickly. So I just tinned all the wires and the ESCs. Now I'm just gonna install the ESC power wires onto the ESCs. And then on the ESCs, just install the signal wire right here where it says PWM on the KISS 24 amps. Alright, so this is ESC 1. It's ready to go on the quad. So I'll just show you how to do one of them and then you can figure out the rest. Okay, so first, before you mount the motor onto the arm, go ahead and slip on the big arm ESC if you are using it, because if you don't do it now, you won't be able to do it later. And then you're just going to thread the motor wire through this little hole. So you're going to mount this backwards because we're mounting the ESCs on the bottom of the frame instead of the top. It's a little more work, but I think it's worth it instead of getting the ESCs destroyed all the time. It's a good way to protect them from the props. And you're just going to slip on the ESCs for the heat shrinks for the ESCs, and then push them under. Just make sure you have the signal side up, not like this, but like this. Push this through. And then next we're going to install the ESC wires, or the motor wires, onto the ESC. So, just kind of move it around. So next, you're gonna kind of push this down. Make sure the wires are kind of seated flat, and then you're gonna go around this way. Put the wires on the other side, and then pull them kind of tightly, just to make sure your ESCs are sitting flat, and then just kind of measure out how much wire you need. I didn't put a cheat sheet on this one because you want this wire to be kind of snug. So just cut out however much you need. And then you're just gonna pre-tin the wire and the pad and then just solder it on. I'm just going to use my hand to pull it tight just so it's taut. I'm going to tack it down, and then I'll use some pliers to make sure it's flat. Okay, something I forgot to mention, I got lost in making this video. I was gonna prepare all the ESCs with the motors, with the correct signal wires, 1, 2, 3, 4, and then I was gonna go ahead and put the jumper on the ESCs, because there's a little jumper on the KISS24 ESCs right here. These two pads. If you solder if you bridge this pad together, it'll reverse the motor direction, because I know on these Emax motors, motors 1 and 3 need to be reversed. So I know I messed up on the video, but before you solder on the ESC onto on the frame, go ahead and put a solder bridge on these two pads right here for motors 1 and 3. So I just installed the motors and the ESCs onto the frame, and I jumped the little jumper to reverse the motors on ESCs 1 and 3. So since we're using a KISS flight controller, the motor signal direction will be motors 1, 2, 3, 4. So just make sure you have the if you're using this cheat sheet, just make sure you have the correct length cut for each of the signals 1, 2, 3, and 4. So next we're going to install a 12 volt pololu step down voltage regulator onto the PDB. This will be for the FPV equipment. Really, you could install the FPV equipment, the video transmitter and camera directly to the power distribution board, but that's not good practice, because really it will work, but because these ESCs send so much noise and voltage spikes back into the system, eventually it's going to kill your FPV transmitter or your camera. So I'm just going to show you the correct way to install the FPV equipment. So what this does is, I'm using a 12 volt 600 milliamp step down, meaning it'll take voltages from I think 12 to 42 volts and bring it down to a regulated 12 volt. So the easiest way I know to install these pololus on a flat surface mount is, first I put a little bit of solder. I pre-tin these pads right here, but with very little solder. And then once I have these pads soldered, I'm just going to put solder through one of these holes. And then once I have that, I'll line up the pololu. And then I'm going to tack this one down. Oops. and wait till it dried. So once that's down, you can go ahead, whoops, make sure it's straight. It's a little crooked. Okay, once this one is down, you can go ahead and put solder through the rest of these holes. And then the solder should go all the way through and touch the pre-tinned lead on the other side. So next we're going to install the XT60 battery cable. So I'm just going to use my little cheat sheet here again and then cut my battery cable to the length I need. And then I'm just going to prepare the XT60. So I have my XT60 cable wrapped in the wire wrap and heat shrunk around. So I'm going to so now I can install it on the PDB. When you're doing these big fat cables, it's easier to. Well, I'm going to turn up my soldering iron to about 850 right now. But it's easiest to melt the solder on the big part on the PDB first, and then touch the wire to this melted solder on the board. That way this one will melt the cable a lot faster, and it makes installing these fat cables a lot easier. So once I have it tacked on, I'm just going to use a little tweezers and kind of push it down. And then make sure it's seated on there well. Alright, now I have the power cable connected to the PDB. I can go ahead and hook it up to the battery. Well, first, before I do that, I'm just going to use this multimeter and check for any obvious shorts. I always do this before I plug up any new system. Okay, so it's telling me that I don't have any shorts in the system. So now I'm going to plug a battery up to this, and then I'm going to check the voltage coming out from the pololu. So that's a 4S battery, and I have it set to the 20, so I should be getting 12 volts right here. Yeah, pretty close. 12 volt, should be nothing here, because this one's for this regulator. Okay, so my pololu is seated correctly, and I'm getting 12 volts out of for my FPV system. Now we'll install the harness for the FPV camera and the transmitter. So since I'm using this FX799T, the wiring diagram will be like this. It comes with two plugs like this. This is the power input, and then this one you're not gonna need. So, well, actually, you will need some of it, but not these two on the end, because that's the output. But we're going to be powering our camera directly off the power distribution board from the pololu. So you can remove these outer two. They look like a light red and a dark brown or something. So you can remove these two wires, and then the rest we'll just use. Just cut it to the length you need. But I'm just going to use my little cheat sheet here for the VTX cable. And then for the camera, we'll be using this one right here. So in case you're wondering, this cheat sheet will come with a kit that I'll be putting together for this SCX200. Kit will include all the parts, all the ESC heat shrinks, all the pololu, XT60 cable, and any other tiny little miscellaneous parts that you might need to complete this build. But if you're not using the kit, you can just you can source your own parts. Alright, so I just pre-tinned all the wires on these FPV camera and video transmitter. So the way you're going to hook this up to the power distribution board is very easy. We're just going to connect it to the power on the 12 volt pololu, the 12 volt, and then the video will go on the video. So first I'm just going to install the video wire. I'll just put these together and then just put it on the video. And then next one will be the positive, which is the 12 volt out. Since I'm using the FX799T, which is a 12 volt video transmitter, and the HS1177 is a 12 volt camera also, I can just connect the power onto the 12 volt out of the pololu. And then next will be the ground. I know it's a little hard to see what I'm doing, but I'll show you what it looks like once I'm done. So this is what the VTX wire and the camera wire should look like once you have it installed on the power distribution board. As you can see, I have both the videos going into one pad on the video, and then positive on the positive, negative on the negative, and make sure you have it on the correct set for this wherever you have the pololu, whether it's on regulator 1 or 2. If you have it on 2, you can do it here. If you need 5 volt if you're not using a KISS flight controller and you need 5 volt, you can use a 5 volt pololu on this side and then output the 5 volts here. But since I'm running a KISS, you can power the KISS directly off the battery. I won't be using this one. Okay, so now we're going to prepare the KISS flight controller to be mounted onto the quad. But it's good practice to always flash your flight controller before you start doing any soldering on the flight controller, because that way you'll know if you have any issues with the flight controller, you'll know before you start installing onto your quad. So if you install it on your quad and then you try to flash it and there's a problem with it, you'll have to take it apart and redo everything. So for the video, I'm going to show installing the KISS flight controller onto the quad first, and then we'll do the flashing part later. But actually, I just got done flashing the KISS flight controller here just to make sure it works. So for the video, I'll skip the programming part for after. So first, we're just gonna tin all the power or the pads that we're gonna be using. So I know we'll be doing PWM1, which is the signal 1, and then we'll do signal 3, and then the other side will be signal 2 and then 4 over here. And then on this side, this side we'll do the pads for the XSR receiver. And then this one right here, auxiliary 1, will be for telemetry. And now I will install the buzzer on the quad. So I'm just going to use my cheat sheet again and cut this. So we'll be mounting the flight controller like this, with the arrow pointing the front. So I'm going to place my buzzer somewhere over here. So just make sure when you solder it, it's facing like this. So pre-tin my leads, and then the 5 volt for the buzzer, and then ground buzzer, and then just solder 5 to 5 and ground to the ground. So it'll sit something like this on the quad. And then I'm going to go ahead and install the vbac cable. Just from experience, I know because of the way the SMA sits on this quad, there's not a lot of room in between for the XSR. So I'll be placing the vbac cable on the top with no header. So I'm going to directly solder a wire from the vbac to the PDB. So I'm going to put it through the top like that. There you go. Our KISS is ready to be mounted on the quad. So now we can install the KISS onto the quad. But before I put the KISS on, I'm gonna put these little O-rings onto the standoffs because it's always a good idea to soft mount the flight controller onto the quad. Signal 1 and 3 is on the top right here, 1 and 3, and then 2 and 4 is on the direct opposite side on the bottom. So first I'm going to install ESC signal 2. I'm going to do the ones on the bottom because it's they're the harder ones to do, and this is so tiny it's hard to see. So I'm going to put ESC signal 2 facing up like this. Two is right there, and then I'll put 4 right there. Alright, so I got 2 and 4 on the bottom. Now I can flip it over. And then I'll put, actually 1 I'm going to put under just to kind of clean everything up on top. I'm going to put 1 under, and then I'm just going to kind of roll it over like this. And 3 will just go directly on top. So when you're done, this is what it should look like. 1 and 3 on top, and then 3 and what is it? 3. Wait, 3. No, sorry. 1 and 3 on top, and then 2 goes on the opposite side of 1, and then 4 opposite side of 3. And the next we'll just install the vbac cable. Alright, so the vbac, I've got some hanging over here. I'm just going to measure out kind of how much I need to go onto the power over here. And then just cut. You want to leave yourself a little extra room in case you need to remove the KISS to do any work on it. Okay, so this is what it should look like once you have everything soldered. I have the vbac directly onto the power distribution board because the KISS can take the power right from the battery, and then I have all the ESC signals. So now we're going to install the XSR receiver. So this is the harness that comes with the XSR. You're going to remove this green wire because the green wire is PPM and we're not using it. We're running this one on S-bus. So remove that, and then I'm just going to use my little cheat sheet again to cut the length of wire. So I've got yellow, a little bit different length than the other ones because the way it's it sits on the quad. Alright, so I'm just gonna go ahead and pre-tin this. Strip the wire and tin it. Okay, so I've got the wires pre-tinned. Now I'm just gonna install it on the KISS. So the way you're gonna install it is you're gonna go white here, and then red. Easiest way to do this is melt the solder on the KISS and then just push this thin little wire in. It really helps here if you pre-tin the small little wires. So if you try to put the heat directly on this wire, you're just going to destroy it. And then the yellow will go on auxiliary 1, and this is our telemetry wire. This is where it'll tell you your RSSI, your voltage, and all that good stuff from the XSR. Alright, so after you've done this is pretty much all the soldering that we're going to be doing on this quad. At this point, all the soldering is done. All we have to do is put the rest of the quad together. Okay, so next we're going to set up the KISS flight controller. So in order to do that, you have to program your Taranis first. But for the sake of saving time, I'm not going to show how to set up the Taranis because I did a pretty detailed setup video in my QAVX build part 2 on how to set up everything on the Taranis for the KISS flight controller. So the way I'm setting up this quad is exactly the same as the QAVX. So I'll put a link in the description below, and then just go watch that video on how to set it up. So I've already got the model loaded on my Taranis.
Gentlemen, welcome to Flight Club.
0 volts engine off.
The only thing different I'm doing is, since this will be a race quad, I'm setting a timer on this a little bit different. So what I have here is there's a timer 1 and timer 2. So timer 1 is exactly like what the other video showed. It's on timer T, meaning that the timer will only start when when my throttle is above 0. And then I'm gonna have the persistence off. Minute call will be checked. Minute call is just every time you reach a minute point, it'll call out 1 minute, 2 minute, 3 minute, whatever. And then on the timer T, I'll have the countdown set to silent. And then for the actual timer, I'm gonna set up timer 2 for 2 minutes on throttle T. So 2 minutes is basically how long each race is, 2 minutes. And then I'll have persistence off, minute call off, and then for the countdown I'll have voice. So what this does is sets the timer for 2 minutes, and then when it reaches a minute 30, meaning there's 30 seconds left, it'll call out 30 seconds, and then at 20 seconds it'll call out 20 seconds, and then when it gets down to 10 seconds left, it'll count down from 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So I'll give you a demo of that real quick. If I go to my telemetry screen, you'll see my timer T, timer 1 is 0 right now because I haven't given it throttle, and then my T2 is the race timer. So once I hit my throttle up, you'll see the timer starts. This is the overall time, and then this is my race time counting down. So I'm gonna fast forward this video to about 40 seconds left so we can see what actually happens.
One minute.
Okay, so we're down to 40 seconds, 39, 38. When it hits 30, it should tell you 30 seconds.
30 seconds.
And then it'll say it again at 20 seconds. So it's counting down how much time is left in the race.
20 seconds.
And then when it gets to 10, it'll count down to 0.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 2 minutes, 0.
Okay, so that's just a nice little timer I like to set for racing. It just kind of tells you how much time you have left before the race is over. So everything else on this Taranis is set up exactly the same as as the video showing you how to set up. Here's the logic switches, all my special functions.
Engine on. Engine off.
This tells you
0 volts.
voltage. Okay, so before we move on to binding the XSR to the Taranis, I have to apologize. Earlier when I showed connecting the vbac onto the KISS flight controller, I had the wires backwards. I had negative going to positive and positive going to negative. So when I plugged it up earlier, it fried my entire system. It fried the KISS flight controller and all 4 ESCs. So I went ahead and I changed the KISS flight controller and all 4 ESCs. So when you're connecting your vbac to your power distribution board, make sure you have it connected correctly. Negative to negative, positive to positive. Because if you don't, it'll fry your whole system like it just did mine. Sorry about that. My head is so screwed up right now. I'm on all sorts of cold medicine and I'm just all foggy. Okay, so make sure you have your vbac connected correctly, and then we're gonna bind the XSR to the Taranis. So to do that, just turn on your Taranis.
0 volts. Engine off.
Hit menu, hit page down, and then scroll up to where it says bind. So make sure you have your mode set to D16, channel 1 through 8, and then just go down to bind, hit bind, and then just hold down the failsafe button on the XSR while powering up. I'll do it like this so you can see. I'm gonna hold the button and plug it in. You'll see the XSR start flashing like that. Unplug the battery, let go of the button, and then when you exit out of this, it should turn green, and that means you're bound. Alright, so now we can set up the KISS flight controller. Once again, I'm not going to show how to flash the KISS because I did a pretty detailed video of that in the QAVX build and the KISS flight controller setup build. I'll put links of that in the description below. So go ahead and go flash your flight controller and then go back to this screen. And then when you connect, you should see something like this. So I'll quickly just go over the settings I have for this quad. So the UAVX type, just make sure it's on quad X. Receiver FrSky S bus because we're running the XSR in S bus with the telemetry wire connected to auxiliary 1. And here are my PIDs for this setup. So you can just kind of play around with these rates until you get a setting that feels right to you. But these PIDs right here should work for this setup. And then for the general settings, min command is 1060, max 2000, min command is 1000. Default is 1070, but if you want air mode, you have to set this to 1000 and then have the arming set to a switch. And then I have one shot 42 enabled because I'm running the 24 amp ESCs, the KISS. And then the FC rotation is none because I have this flight controller pointed in the front direction. And then these are my settings for my switches. So in the auxiliary 1, I have level mode or the flight mode set up to this switch. My arming is set up to this switch. And then buzzer is over here. So after you do all your settings, make sure you hit save. But as a safety feature in the KISS configurator, if you have a battery plugged up to your quad, you can't save. So just make sure your battery is not plugged in, and then save your settings, and then we'll move on to the motor testing. So before we test the motors, make sure you have the props off for this one because you don't want to chop up your face with the props or anything like that. Okay, so go ahead and turn on the quad.
Gentlemen, welcome to Fight Club.
0 volts. Engine
You
off.
should already see it connected, and in the KISS configurator, you don't need to have a battery plugged in for the receiver to work. So before we go test that, just go ahead and calibrate your accelerometer. Make sure your quad is on a flat surface, and click this and don't move it. Just let it do its thing, and then it'll level. And then go ahead and plug in your battery. So click test motor. I know what I'm doing. And then enable motor test. And then here we're just gonna make sure the correct signal is hooked up to the correct motors. So we're gonna test motor 1 first. And it's spinning clockwise. Well, go back here. It'll tell you right here, this is PW motor 1, 2, 3, 4, and then it'll show you the direction that they should be running. So 1 and 3 are clockwise, and 2 and 4 are counterclockwise. So I'm gonna go back here and do this again. Test motor. So this one should be clockwise, which it is. Number 2 is counterclockwise, which it is. 3 clockwise, yep. 4 counter, yep. So mine is already spinning the correct direction because before I mounted the ESCs onto the frame, I soldered the jumper on the ESC so that it reverses the motor. But I know for the Emax motors, it's 1 and 3 that need to be reversed, but it's different from different kinds of motors. So you might just need to play with that and then figure out if you have it right or not. So if you have a motor that's spinning in the wrong direction, just either open the jumper or connect the jumper. That'll just reverse the motor direction. So once we have this tested and made sure that everything is spinning the correct direction and each motor is correct, we're pretty much done with the KISS configurator setup. Now we can finish putting the rest of the quad together. First we'll install the VTX using this little plate. So this little plate that comes with the quad is for the VTX. Go ahead and slide in the SMA into the square with the longer part facing up. So it's going to be like this. And then there'll be a little O-ring in the kit. Slide this on. And then connect it to the back plate where the LED is facing out like this, and then screw in your antenna. And then once you screw this in, it'll lock in the SMA in place and take all the pressure off the little soldered area. Now the SMA is ready to be installed on the quad. So now we'll install the FPV camera using these the side plates and these rubber things. So the small tab on the quad will go on the bottom, and the bigger tab will be on top. So they're gonna mount like this, and then this little slot thingy goes towards the back. So go ahead and use this the rubber thing and push it through the hole. This. Once you have the rubber through the carbon fiber, put it onto the hole in the camera, and then there's a little white disc that comes with the kit that goes in there, and then the little tiny Allen wrench or the cap screw goes inside, and it takes a 1.5 millimeter screw driver to screw this in. And then just do the same thing for the other side. So once you have this, the 2 plates on, you're gonna get one of these little metal disc thingies and put it in the back. And then use one of the thumb screws for the adjustment lock, the angle lock screws. Alright, so this is what it should look like when you're done. This little screw thing will lock in the angle that you have it set to once you have it mounted on the quad. I'm just gonna leave it loose for now until I install it. So now that we got the VTX and the camera mounted, we can put everything onto the quad. So go ahead and thread the VTX cable through these little holes in the back of the SMA plate. And then just slide on just put them into the little slots on the bottom of the quad. That. And plug in your camera. Okay, so at this point we're pretty much done with the build of the quad. I just closed up the heat shrinks on the arms and the ESCs, and I just used some zip ties to hold the antenna in place. There's just one last thing we need to do before we go fly, and that's to set the failsafe. So in the races, they want you to set your failsafe to where if you lose signal from your Taranis, they want you to have the motors just cut off. So just make sure your quad is disarmed and the throttle is at 0. And then just gonna plug it in first. Plug it in, and then just quickly push the button, the failsafe button on the XSR, and you'll see it flash. And the failsafe is set. So we're just gonna test it. So we're gonna arm, flying, blue signal, and we're set. So I'm just gonna put on some props, and then we'll go take it out for a test flight.